sectors. And sectors. We're going to draw a lot of circles today. We're going to draw a circle with our centers still. Do you guys want to make really good circles that I can't do up here, but you guys can all do? Yeah, grab a washer from up front. So up, up, up. Get up. Yes. The metal things. Grab one. It's going to help you.
Hands put it back when you're done today.
Yeah.
I'll get a new sheet if you don't go. I'll have to sign if you get back there.
Okay. Draw a circle on your sheet. And then I want you to do 2 radii. Whichever way you want. I'm drawing it here as such. And each point that it touches circle, I'm going to call A and B. What do you want to call our center, Camille? C? Okay. Center will be C. I just made an angle between A and B as such. I'm going to call this theta for now. Angle theta. This angle in the middle is called a central angle. And it's the angle formed between 2 radii. So you can draw it however you want on your sheet. You got 2 radii, there's an angle in between. And right now I want you to all add another point over here. Well, let's call this D. Why not? Not where 2 radii make our central angle. On the other side. Lily, which one do you think is bigger? This arch right here? Or this arch over here? This one? Bigger? Yeah. Yep, I'm going to call that a major arc. Because it's bigger than the other one. So a major arc. Ooh. Major arc. Which is denoted as, in our case, A, D, B. And instead of putting a line, because we're not talking about a line, we're talking about an arch. So I'm going to draw my arch as well, above it. Not a straight line anymore. Major arc is larger than a semicircle. Carson, how many degrees are in a semicircle? Yeah, 180. Vincent, how many degrees are in a whole circle? Yeah, 360. So half of 360 is 180. So a semicircle is half of a circle. Now this is a major arc. What do we think we call AB? Minor, yeah. Minor arc. So minor arc, we're going to say it's AB with an arc up above it. And it is smaller than a semicircle. So a major arc will be greater than a minor arc. So these arcs have a length and they have a degree measure. They are two different things, and we gotta talk about them two different ways. When I do a degree measure, I'm gonna put star, degree measure, that's denoted as like m of a, b. And it's equal to the central angle of AB. Which is actually ACB, denoted as that. So let's do an example. Draw another circle. Ooh. Draw it as so. Put, let's call this P, a center P. This A, B. And I'm going to call this angle right here. Raylene, what do you want to give it? How many degrees is this angle right here? Any number you want. Less than 360. 3? 30. 30, okay. 30 degrees. So if angle APB equals 30 degrees, I want you to find the degree measure of AB and the degree measure, so that's M, of ACB. I want you to find both of those degree measures. Talk to your partners next to you. And degree measure of ACB. And the same thing would be AC. Okay, Camille, how did you guys start? Equals what? Yep, 30 degrees. So if the angle in between here is 30 degrees, this degree measure of the arc is 30 degrees. Yeah? Okay. Now, what about the degree measure of ACB? 30? 330. How do we get 330? So this entire angle right here is 330. So we do 360, that's the entire circle. We knew that this angle right there was 30. And then I'm just left with 330 degrees. Vincent, which one is my minor arc? Say it again. I'm so sorry, Vincent. Say it again. AB, yes. So which one is my major? Yeah, ACB. Yep. That was so weird. So this was my minor, this was my major. What are they doing in science class today, guys? I know. Okay, so that's my major and that is my minor. Now, we're looking at the angles, right? But I also want my length of that arch right there as well. Okay, so we're going to talk about arch length to circumference. Arch length to circumference. Do you guys remember the formula for circumference of a circle? Thumbs up or thumbs down? I just want to know. Lily, you know this because we talked about it already. Today. Yeah, so circumference equals 2 pi r. But that is a full entire circle. We aren't always talking about a full circle. And this one, this would have been my arch length right here. But that's not the whole circle. It's only a part of the circle, right? Okay. So a part of the circle, we're going to denote, okay, we're going to draw a picture first. So draw another circle. We're drawing a lot of these right now. I have my 2 radius again. And we have an angle right in the middle. And instead of theta, we're going to do n degrees. Because it's always an n degrees for you guys. Because we're not going to talk about radians in this class. Lily, we will in algebra. Okay, n degrees. Okay, an arch length is s. So s equals arc. I'm sorry if I keep calling it arch. Arc length. N degrees is just central angle. Okay, so S is a portion of the entire circumference. So that's S divided by 2 pi. This is going to equal, well, how many degrees are in an entire circle? Okay, so 360. And we only want part of that degree. So that's n degrees is part of that entire circle. So how do I get S all by itself in this formula? Or not a formula yet. Yeah. Multiply by 2 pi on both sides. So the arc length formula for this is S equals n degrees divided by 360 times 2 pi. So let's do an example together. Let's draw another circle. let's, oh guys, I forgot about R. That was so funny. Entire time. R. Include your R's. Forgot about my radius. Okay, well, we're gonna draw a radius. Raylene, what do you want the radius of the circle to be? 20. Okay, big circle. Doesn't look like it, but it's a big circle. Vincent, what do you want a degree central angle to be in the middle? How many degrees? What? Any you want. That's in between 0 and 360. Okay, I fell into that. 67 degrees. Can you guys find me the arc length of, let's add some numbers here, A, B, adding letters, P, and this is the C out front. So find arc length of A, B. Drew, is AB a minor or a major arc? Yeah, minor. So we're looking at this one right here, the minor one right there. So find me S. What does it equal? Oh, Carson, great question. I don't want you guys to calculate pi. I want you to keep pi in the answer. So it's something pi. I mean, you can just type, there's a pi. Do you want me to show you what pi is for future reference? Future reference. They won't say off length. They just say length. Because the little hump above just means off. It's not 5, guys. It's S. That's yes, that's an S. Yep. What's our radius? What did you tell me the radius was? Yeah. I'm going to keep pi in the answer.
How would you keep pi?
Just don't multiply it by pi. Calculate it. 60? Yeah. Yeah. Okay, let's plug in some numbers. Drew, which one do you want to plug in? What do you know? Okay, 20 is all what? It's in my circle, and it goes from my center to a point on the circle. So that's called my, starts with an R. Yes. So that's my radius. If I go from the center to any point in the line on the circle, it's radius. So I have 2 pi, and that's my radius of 20. Now, what is my n degrees in this problem? Yep, 67 degrees. And I put that in calculator without pi. So I would have done 67 divided by 360, which was 0.18661 repeating, times 2 pi 20. What would you plug in next? What would you multiply together? So multiply by 2, then 20? Yeah? Vincent, what did you get when you put that in your calculator? I don't want you to type in pi. I want you to keep it in terms of pi. So just do it what Lily said. The decimal times 2 times 20. Yeah. So it's 7 point, say again, 4 repeating. Okay. And don't forget pi. And this is a length, not a degree. So we don't add degrees there. Okay. We're going to do some practice problems. Why don't you all get up in your groups, same groups, and I will have one up on the board. Okay, sketch what I have up here on yours. So I want you to find the length of WZ, the arc WZ. Lily, that is the smallest drawing I've ever seen. Yep. So this is 73, this is 43, this is 104 degrees. And keep it in terms of pi.